Welcome students, this is again Ravi Shankar, and today we are going to study about the electrical potential at a point due to a point charge. In our last class we have studied about electrical potential energy. From electrical potential energy we have derived and defined electrical potential difference as well as electrical potential at a point. For that electrical potential at that point, today we are going to derive an expression. Before deriving that expression, let us recall the definition what we have already studied. So electrical potential at a point due to a point charge. That electrical potential at a point is defined as the work done in moving an unit positive charge or test charge from infinity to a point inside the electrical field against the electrostatic force. Here, if the charge is positive charge plus Q as the parental charge and the test charge is unit positive charge, then the electrostatic force is repulsion. So I have written it here as repulsion. So how to obtain an expression for this electrical potential at a point due to a point charge? For that I am considering a simple diagram. In air medium I am considering a point O where I have placed the test charge plus Q. At a distance R from the point charge at O, I have considered another point P, and at this point P I have to calculate this potential due to this charge plus Q. So how to calculate? We know that if you are having a positive charge, then around this charge you will be having what? An electrical field. So inside that electrical field at this point, what is the potential? So before going through the derivation, let us consider a small description for this diagram. So you consider the description like this. Consider a positive charge. Consider a positive charge and let that positive charge be plus Q kept at the origin or kept at the point O. Let P be a point. Let P be a point at a distance R. At a distance R from the point O. Or we can say from the charge Q. From the charge Q at O. Okay. So how to get an expression? See, already in our previous class or in our previous question regarding the potential energy, we have derived the electrical potential at a point in simple equation. So we can say we know that the electric potential at a point, here the point is P. At a point, here let us consider the point is P, is given by, what is that formula? Potential V is equal to, that is, if it is potential difference, then we can say that E vector dot dr vector. Since it is potential, we have to integrate it from infinity to the point, or infinity to the point is at a distance R. Since the work is said to be done against, we have to state minus. So we can write this as V is equal to minus of integral infinity to R E vector dot dr vector. Already we have derived this expression in the previous question. Here we know that here E vector is considered to be electrical field at the point P. E vector is electrical field at the point P. What is the value of that electrical field? That also we know. So we know that electrical field E vector at that point is given by the formula, or we can say E vector, that is electrical field at a point, due to a point charge, is given by, due to a point charge Q is given by E vector is equal to 1 divided by 4 pi epsilon 0 Q divided by R square into R cap. Already we have derived in the beginning of this lesson while we are studying about the electrical field. Now what we can do, you take this and substitute in the above equation, we can able to get the value for V. So we write like this, how substituting for E in V, we get what you can able to get. See, you take this and substitute in this equation, you can say the potential difference V is equal to minus of integral infinity to R. Instead of E vector, I can substitute 1 divided by 4 pi epsilon 0 Q divided by R square into R cap dot dr vector. So this we are considering it as the substitution. Now we have to simplify. So in order to simplify, let us take the constant quantities which cannot be integrated out of integration. So minus of 1 divided by 4 pi epsilon 0 and Q. Then integral of infinity to R, we can write 1 divided by R square R cap into dr vector. How I can simplify this? See, in order to simplify this, I am taking this dr vector and writing it. See, but how I can write this? But we know that. So I can say, but we know that. I can write like this, dr vector can be written as the magnitude of dr vector dr multiplied with the R cap. Also we know that I cap or I dot I is 1. So I can write R cap dot R cap is equal to 1. So taking these two in the above equation, I can write the potential V as, see, 1 minus of 1 divided by 4 pi epsilon 0 into Q, integral of infinity to R, 1 divided by R square into, instead of R cap I am writing the R cap as it is, into, instead of dr vector I am taking this and substituting as dr into R cap. Here you see R cap dot R cap will become 1. So this can be written as minus of 1 divided by 4 pi epsilon 0 into Q, integral of infinity to R, 1 divided by R square. By leaving R cap dot R cap as 1, I can write it out as dr. So I can able to get the magnitude alone. What is the integration for 1 by R square? 1 by R square, when it is integrated, you can able to get it out as minus 1 by R. So you integrate it, P is equal to minus of 1 divided by 4 pi epsilon 0 into q. When I am integrating this 1 by r square, I will be getting it as minus of 1 by r, and if you want minus of 1 by r, and after getting minus of 1 by r, you substitute the limits, that is from infinity to r. So on substituting the limits, you can get minus of, see this minus and this minus will become plus. So 1 divided by 4 pi epsilon 0 into q multiplied with the upper limit, it is 1 by r, minus the lower limit 1 divided by infinity. 1 by infinity will tend to 0. So I can get the result. What is the result then? The result that I can able to get is, therefore I can able to get the potential V is equal to 1 divided by 4 pi epsilon 0 into q divided by r. This we are calling it out as the expression for electrical potential at a point due to a point charge measured in terms of an unit called to be volt. So this expression, or I can say this equation, gives or represents the electric potential at a point, represents the electric potential at a point, electrical potential at a point due to a point charge, due to a point charge. See, from this we can say, see, therefore I can say V is inversely proportional to the distance from the point charge to the point where I have to calculate the potential. Now, after studying this expression, see, if you want to recall, we can recall this. When you are considering this, you see, when I am taking the electrical potential at a point, I have defined first of all, what is the definition? The definition is electrical potential at a point is defined as the work done in moving a unit positive charge or a test charge from infinity to a point inside the electrical field against the electric force of repulsion or against the electrostatic force. Now, in order to derive the expression, I am considering a simple diagram. In air medium, consider a point O where a charge plus Q is placed at a distance R. You consider another point P, and at this point P, we have to calculate the potential. Now, you write or consider a small description. Consider the positive charge plus Q kept at the point O. Let P be a point at a distance R from the charge Q at O. So, we know that the electrical potential at P is given by, electrical potential is equal to, V is equal to minus of integral infinity to R E vector dot D vector. This formula already we have studied it in our previous video in potential energy, from where we got this potential. So here E is known as the electrical field at that point. We have calculated the electrical field at that point, and the expression for the electrical field at that point due to a point charge is given by E vector is equal to 1 divided by 4 pi epsilon 0 into Q divided by R square into R cap. Take this and substitute in the previous equation. We can state, substituting for E in the above equation, we get the potential V is equal to minus of integral infinity to R 1 by 4 pi epsilon 0 Q by R square into R cap into dr vector. So taking the constant quantities which cannot be integrated out of integration, we get minus of 1 by 4 pi epsilon 0 q into integral infinity to r 1 by r square r cap dr. Now you see, I can write this dr vector as dr, that is the magnitude of the distance is dr, into r cap. Also we can say r cap dot r cap is equal to 1. So considering this in mind, I am replacing the above equation as v is equal to minus of 1 by 4 pi epsilon 0 into q, integral of infinity to r, then 1 by r square. Instead of dr vector, I am writing r cap into dr multiplied with again this r cap. So I will be getting it as r cap into r cap as 1. So the answer is minus of 1 by 4 pi epsilon 0 into q, integral infinity to r 1 by r square into dr. I think you know integration. When you are taking this to the numerator, r power minus 2, when you are integrating, you will be getting r power minus 1 by minus 1. So I will be getting the potential V is equal to minus of 1 by 4 pi epsilon 0 into q. When this 1 by r square is integrated, I will be getting the value as minus of 1 by r within the limit infinity to r. Taking this minus out, I can get minus minus will become plus. So 1 by 4 pi epsilon 0 into q. Applying the limits, upper limit 1 by r minus the lower limit 1 by infinity. 1 by infinity tends to be 0. Therefore, V is equal to 1 by 4 pi epsilon 0 into q by r. And it is measured in terms of an unit called to be volt. This is taken to be the SI unit. Now, from this expression, we can say that the potential V is inversely proportional to R. And this equation represents or gives electrical potential at a point due to a point charge. Now, we have to get some of the important aspects of this potential. So, let us consider the next format. That is, we are going to consider important aspects of what? Important aspects of this potential. What are the important aspects? Point number 1. See, when you are considering the source charge, it may be either positive or negative. So, let us consider. If the source charge, what will happen? If the source charge is positive, that is plus q. Or I can consider if the source charge is minus q, negative charge, that is minus q, what will happen? See, if the source charge is positive, that is plus q, then the potential available V will be greater than 0. Because when we are considering the formula is, what is the formula? Since the potential is given by the formula, V is equal to 1 divided by 4 pi epsilon 0 q divided by r. So, when you are considering this charge as positive, then this potential V will be greater than 0. If it is minus q, then the answer potential V will be in minus. So, we can say then the potential V will be less than 0. This is the first point that we can consider. The second one, if you want to describe the motion of the objects, we can describe the motion or the moving objects or the moving charges using the concept of the potential or potential energy. This using the concept of potential or potential energy is found to be easier and simpler compared with explaining with the help of electrical field. So, we have studied about the electrical field as well as the electrical potential. In order to describe the moving objects, it will be easier for us to describe it with potential energy or potential than with electrical field. That is the second important aspect, that is describing, or we can say description of motion, description of moving objects or description of motion. So description of the moving objects or motion of objects using the concepts of potential or potential energy is found to be simpler than electric field. Than, we can say it out as than electric field. That is the second point. What is the point number 3? See, already I have stated when you are considering this potential V and the distance R, all the other quantities are constant. So potential V and the distance R are inversely proportional. So I can say, see, since the potential V is inversely proportional to that of the distance, the potential decreases as the distance increases. That is, the distance of the point considered increases as the distance increases, and vice versa. Vice versa means if you are considering the potential is the distance being decreases, then the potential increases. We can say right like this: potential decreases as the distance increases, and I can state it out as vice versa. Vice versa means we know the potential increases as the distance decreases. Okay, if you are considering the distance as infinity, that is at infinite distance, that is r is equal to infinity, then potential will be equal to 1 by infinity, which will become what? Which will tend the potential to become what? To become 0. So at infinite position, the potential is considered to be 0. So this we are considering it as the third important point. Let us go for the fourth important point. In order to study the fourth important point, let us compare this potential with the gravitational potential, what you have studied it in your 11th standard. See, let us take like this. In case of gravitational potential, see, the mass moves from higher gravitational potential to lower gravitational potential. Higher gravitational potential to lower gravitational potential. See, let us use this to compare the electrical potential. Similarly, so when I am considering this, similarly, I can say the positive charges moves from, the positive charges are considered to be higher amount. Positive charges move from higher potential to lower potential. Higher potential to lower potential, and vice versa. What do you mean by that vice versa? And the negative charges, when you are considering about the negative charges move from lower potential to higher potential. Lower potential to higher potential. This we are considering it as the fourth important point. See, in order to study about the motion of the positive charges as well as the movement of the negative charges, we have compared this with the gravitational potential. In case of gravitational potential, we have to consider the mass. The mass moves from higher gravitational potential to lower gravitational potential. Similarly, when you are considering the positive charges in electrical field, it always moves from the point where the potential is higher to the point at the lower potential. Similarly, when you are considering, instead of a positive charge, if you are considering negative charge, then the charge will move from the lower potential to the higher potential. So let us go for the final point. Instead of having a single charge, if you are considering electrical potential due to multiple charges, what you can able to do? See, we have studied about the superposition principle. Similarly, here also I am going to consider. If multiple charges are considered, what will happen? If multiple charges are considered, what will happen? If you are considering the multiple charges, let us take like this. You are having a charge Q1, Q2, Q3, etc. up to Qn, and you consider a point P. This Q1 and P separated by distance R1, Q2 and P separated by distance R2, Q3 and P separated by distance R3, Qn and Rp separated by distance Rn. Then what is the total potential or what is the net potential at this point? See, the net potential or the total potential at this point is equal to nothing but algebraic sum of individual electrical potentials. That is, V total is equal to, see, due to Q1 this point will have a potential, let it be V1. Due to Q2 it is the potential at point P to P is V2. Due to Q3 the potential at point is V3, and it is going on, and if you are considering Qn, then the potential is Vn. For all these potentials we have to consider an algebraic sum. If it is positive, add it out. If it is negative, you subtract it out. Here if all are positive, then V1 plus V2 plus V3 plus etc. up to Vn. So this we are considering it as the multiple charges are considered, what is the net potential that is available. See, using this can be written mathematically. How I can write mathematically? See, mathematically I can write in form of sigma. Mathematically, the above values can be written as V total is equal to 1 divided by 4 pi epsilon 0 sigma of Qi divided by Ri. What is this I? This I will vary from 1 to n. These 5 points are considered to be the important aspects of the electric potential. See, another important question which carries 3 marks. If it is asked along with important aspects, it may be asked in 5 marks also. So make it thorough. Let us see in the next class. Thank you. All the best.